Hi, everybody. Good afternoon. This is Derek from SparkFun, and as you can tell, it's a little different today. I'm actually in my shop, and today is going to be episode 2 of our Gator board ecosystem. So we're going to be exploring the Gator. So this will be episode 2, and the reason I'm in the shop is that we're actually going to be building something today. We're going to do a couple of things. We're going to cover what a circuit is, really the basics of a circuit. We're then going to program a basic circuit using the Gator bit and a couple of the Gator boards. And then we're going to show really quickly how to take that circuit and build a really quick project. I'm going to do a little bit of TV cookery, right, where I've done a little bit ahead of time, but I think you'll get the idea of it. So with that, we'll get started. First of all, I want to apologize. This is being the first time we're recording in the shop, and so I have a really squeaky chair. So if you hear squeaks in the background, I apologize, and we'll try to get it fixed for next time. With that, I'm going to jump over to a deeper overview of the Gator circuit kit itself, and then we'll start building and talking about circuits. So we're going to jump to my webcam here. So you see here, this is what we have in terms of the Gator circuit kit. You have a Gator bit itself. You have the Gator color board, which is LEDs, white, red, yellow, green, blue, and then another white. You have the Gator control board, which are 2 buttons, an on and off switch, and a reed switch or magnetic switch. And last but not least, the Gator starter board, which has a temperature sensor, an RGB LED, and a light sensor. Now, all of these boards snap out of their PCBs, and you can tell, especially with the Gator color, I've already snapped some of these out, including the little power strip I have here. Best way to do that is, if I can find them, here they are, to use some needle nose pliers, and I just use to basically grab onto the PCB frame and just lightly snap right down the edges on both sides. You can see where the LEDs connect. You can actually just snap them out at a certain point so that you have these individual boards. And then you can take this, use it for a different project or something like that, but you can just toss it to one side for now. So we have all these LEDs, power strip, and I snapped out one of the buttons. So in the end, we'll snap all of these out over time, but we're just going to use today for the basic demonstration 1 or 2 LEDs with our Gator bit. But I want to really quickly how I like to snap these things out of their frames. Trying to do it by hand on its own gets a little difficult, especially if you are doing a number of these. It's always nice to have a pair of needle nose pliers. Once there's, depending on how you feel with your students handling these, there are spots on the ends, and you can take either a nail file, works fine, or a piece of sandpaper and sand those off as well if you want to keep it nice and smooth around the edges. I'm going to actually put these to one side for now. Talk a little about just the general circuit. In context with the Gator bit, microcontroller idea of just the circuit itself. The idea of a circuit is, but in an electronic sense, there's a power source, and ground at the other end. So current will flow from positive, or our power source, to ground, negative, or sometimes it's called GND. This is out. And on the Gator bit itself, this is 3.3 or 5.0. Most of the time you'll use this. So 3.3 or 5 volts. If we just connected out to ground, we would actually cause what's called a short circuit, meaning that we're creating a circuit, but it's too short. It doesn't have any, it's not doing any work necessarily. And what I mean by work, if we think about this as a track, we want it to be an obstacle course. We don't want it to be a flat circle. We want to add things like an LED or interrupt it with a button. So instead of just a circle, what we want to have happen is that, I'm going to draw another one out here, is that we have it, we use that voltage, that current, to do something like light up an LED. So that that current flows into the LED, flows through the internal components of an LED, which is light to be given off, and then flows out of the LED back to ground. So this is probably the simplest circuit you can have other than a short circuit. Short circuits, when we talk about circuits, a short circuit tends to cause bad things when we're talking about microcontrollers. This is when things get hot and things don't work. We always want our current, our electricity, to do work for us. There are a number of other circuits that we can explore. One of them, one of them is a series circuit. And if you think back to it, if you're old enough, think back to old Christmas lights when one light would go out, all of the lights on beyond it would go out. That's actually a series circuit. And what it is that you put all of the loads, circuit one right after the other. So if I'm on Gator a bit, if I have, let's say, a number of LEDs, I'll leave that one there. Let's take 2 LEDs. If I connect them, so here to there, and again, the plus side of the LED is connected to the plus side or the outside of the LED, or of the circuit. And then I'm going to connect the minus or ground side of the LED to this next one, which will connect to plus, ground, and then all the way around to my ground. So it'll happen here that current will go through this LED, this one will light up, this one will light up, and then to ground. And again, that whole circuit, that complete circuit, will cause the LEDs to light up. But for some reason, if I remove this LED, or it burns out, this LED will not light up because I have not completed the circuit. Let's say if I replace that LED with a button, this button contact. So the current flow is not going to flow because right now the button is not completed circuit, but when I press it, that will flow to the LED, lighting the LED into ground. An LED. Okay, welcome back. Sorry again for the difficulties. It happens with streaming video sometimes, especially remotely. Anyways, we just went over some basic circuits, and one of the things that we're going to do is that we're going to take a look at what do those circuits mean when we're talking about the Gator bit, and then moving into using the Gator bit with the microbit. So it's hard to see it here, but right now I have ground there and there on the microbit. And then I have 3.3 volts here. I have a 5 volt here as well, but we're going to stick with our 3.3 volts. What we're going to do is actually build a circuit using Gator bit as the power supply, and we're going to do that by using this battery pack and plugging it into the barrel jack. When I plug a battery pack in, it's turn on. When I turn on, that means I have both 3.3 and 5 volt out. There's no microbit here yet, but we can just use these power supplies or these power pins to our advantage to build some basic circuits before we program anything. So with that, I'm going to grab some banana clips, banana wires. I'm going to plug them into an LED just to turn on and complete that first circuit. So I'm actually going to insert the banana clip here into 3.3 volt out, and that wire into the plus side of the LED. And I'm just going to use this so I can